question asks us to find the integral of x log squared x dx, and then using that answer to solve when the limits of 4 and 1 are placed. I feel that question B is a little bit unfair, as if you make a small mistake with part A, you're never going to get the right answer and then just waste time. Similarly, if you are unable to do part A, you will never be able to do part B. In general, they should give you the solution to part A if you're required to use it in part B. So I think students who set this paper were a little bit hard done by for this question. In order to do this question, we need to use integration by parts. Integration by parts is used when we have the product, so the multiplication of two or more functions. Now, where does integration by parts come from? It actually comes from differentiation's product rule, so it is the reverse of this. So as you can see with differentiation by parts, you're splitting up d uv dx, where u and v are functions, into u dv plus v du. Rearranging a little bit and then integrating both sides, you can see you end up with the integral of u dv is equal to uv minus the integral of v du. Now, more explicitly, when should we use integration by parts? So we should use it whenever the integral is a product of functions. So for example, x e to the x or x log x. And in general, what happens is that one function becomes simpler when differentiated. So if u is equal to x, du is equal to just 1. And then the other function should be easy to integrate. So for example, if dv is equal to e to the x dx, then v is equal to just e to the x. Taking the formula we derived earlier, let's do an example. So if we're looking for the integral of x e to the x dx, you can clearly see that this is two functions. One function x, the other function e to the x. What we're going to do is choose u equal to x and dv equal to e to the x. From u, calculating du, which is equal to dx, and from dv, calculating v to be e to the x, we then substitute this into our formula. The integral of x e to the x dx becomes x e to the x minus the integral of e to the x dx. Solving for that is just then x e to the x minus e to the x plus c, and that completes integration by parts. Now, what do we do if there are more than two functions? For example, in the question that we have, we're going to have x log squared x, which is basically the same as x log x times log x. So it's three functions. What we're going to do is first do integration by parts, taking two functions together. So we're going to first split it into two. So for example, we can have u is equal to x log x, and dv is then equal to just log x dx. Obviously, we can do any combination that we want for this. You're going to follow the steps as normal, and what you'll see is that often you'll end up with another integration by parts to be done. You then do that, and you'll see that eventually it should all solve. For question 8, doing the integral of x log squared of x dx, we're going to do integration by parts. In this case, I'm going to take u to be equal to the log squared of x, so therefore du is equal to 2 log x times 1 over x dx, and I'm going to take dv is equal to x dx. So integrating that, we've got v is equal to x squared over 2. We can then use the formula for integration by parts that we have, where the integral of our equation is equal to uv minus the integral of v du. Substituting in the values we have, we've got x squared over 2 times log squared x minus the integral of x squared over 2 times 2 log x all over x dx. Simplifying that a little bit, you've got x squared over 2 times the log squared of x minus the integral of x log x dx. Now you can see here that we're going to have to do integration by parts again. And so starting with that integral of x log x dx. So doing the second integration by parts, I'm going to let u equal to log x, so du equals 1 over x dx. And I'm going to let dv equal to x dx, and therefore v is equal to x squared all over 2. Putting that again into the formula, so the integral of x log x dx is equal to uv minus the integral of v du. That equals x squared over 2 log x minus x squared over 4. Then substituting that back into the full formula, we've got the integral of x log squared x dx is equal to x squared over 2 log squared x minus x squared over 2 times log x plus x squared over 4 plus the constant c. For question B, we're going to take what we've just calculated and we're going to add some limits to it. We're to solve it between the limits of 1 and 4. So we start off with the upper limit. So everywhere we see x, we put in 4. So you've got 4 squared over 2 times log squared 4 minus 4 squared over 2 times log 4 plus 4 squared over 4. And then we subtract away the lower limit. So again, we put in 1 wherever we see x there. So you have 1 squared over 2 times log squared 1 minus 1 squared over 2 times log 1 plus 1 squared over 4. Now, solving that a little bit, you end up with 8 times 2 log 2 squared. This is actually the most important part of solving this question. There's a mark going for this, where you need to recognize that the log of 4, if you substitute 2 squared for 4, and then use the rule of logs where you can move the power outside and become a multiplied, so you have 2 log 2, and that's all then to be squared. Then continuing, we've got minus 8 times 2 log 2 plus 4. And then on the lower limit side, 2 of the terms go to 0 because the log of 1 is equal to 0. So the lower limit side simplifies just to minus a quarter. So we end up with 32 log squared 2 minus 16 log 2 plus 4 minus a quarter. You can see this 32 comes from squaring the 2 inside the bracket, which gives us 4, then times by the 8. And so our final answer ends up being 32 log squared 2 minus 16 log 2, and then plus 4 minus a quarter is ending up as 15 quarters. And that is the final answer. Thank you so much for watching. I hope this tutorial made things clearer and helped you tackle this question. Don't forget to like, subscribe, and hit the bell to stay updated when more questions are answered. If you have any questions or need any more help, please drop a comment below and I will get back to you. Until next time, keep practicing and good luck.